Hi everyone, today we're going to be talking about how to solve quadratics by completing the square. We've already talked about how to solve them using the square root method and how to solve them by factoring, and so this is just one more way that we can solve quadratics. In this case, there's a lot of steps, but most of the steps are pretty simple, and so it makes it one of maybe the longer ways to solve it, but it is pretty easy. So we're going to just start with the first example, and I'll show you the steps in this first example. And it's x squared minus 2x minus 86 is equal to 0. So the first step is to get the x's on one side and then the chunk without the x on the other side. So I'm going to add 86 to both sides. I add 86 because right now it's a minus 86, so to get rid of it we do the opposite and add. And what that's going to give me is x squared minus 2x equals 86. Now, the next step here is to get it into, or use this formula, which is b over 2 squared. And this is like my completing the square formula, where b is the number, if you remember, in front of the x. So let me just kind of a side note. A standard form quadratic is in the form ax squared plus bx plus c. So a is the term or the number in front of the x squared, b is the number in front of the x, and then c is the constant term. So when we have this formula that's the b over 2 squared, we're talking about that b is the number in front of just the x. So in this case it's a negative 2, which makes me write negative 2 over 2 squared. I can plug that into a calculator and it's going to give me 1. So this number is an important number. What I'm going to do with it is I'm going to add it to both sides. The reason why I add it to both sides is because what I do to one side, I have to do to the other side. And so I have to add 1 to both sides. But the reason why I choose to add 1 there is because now this side, this left side, is what we call a perfect square. The reason why I know it's a perfect square is because when I factor it, and potentially I could factor it using the box method, but when I factor it, I'm going to get the same factors, same 2 factors. So I'm going to show you how to factor it with the box method, but you should already know how to do that based on the last video. So we've got our box. The first chunk goes in the top left box and the last chunk goes in the bottom right box. We're looking for something that multiplies to be that last number, which is 1, and adds to be the middle number, which is negative 2. So the only things that multiply to be 1 are 1 and 1. 1 times 1 is 1. But in order to get it to add to be negative 2, they both need to be negative. So negative 1 times negative 1 is equal to a positive 1. And a negative 1 plus a negative 1 is equal to a negative 2. So both of these things have to be a negative 1x that we put in these other boxes, which means that my factors, or what we have in common, would end up being x minus 1 and x minus 1. So what that tells me is I can rewrite the left side of that equation as x minus 1 times x minus 1. And then that's equal to 87. Then my next step, and it's 87 because it's 86 plus 1, which is 87 on the right side. So now, if I have the same factor, x minus 1 and x minus 1, there's a cool way that I can write it. I can write it as x minus 1 squared, because squared just means I have 2 of them, which I do. And so now that I have this, it looks really, really similar to one that we solve with square roots. So I have a squared on one side, I don't have a squared on the other. What I'm going to do is actually square root both sides. So square root this side, square root that side. And remember, when I square root something, I have to do a plus or minus. So then the square root and the squared cancel each other out on the left side, and I'm just left with x minus 1 on the left side. And then on the right side, I have plus or minus the square root of 87. Slightly different than what we were doing with the square roots, though, because now you have x minus 1 on the left side. You don't just have x. So you still want to get x by itself. To get x by itself, we would add 1 to both sides. And so I'm going to end up, this minus 1 and plus 1 cancel each other out, and I'm left with x. And then I'm going to end up with 1 plus or minus the square root of 87. And that's as simple as that square root will go, but we could potentially simplify that. If you were really nervous about simplifying it, you could also just plug it into a calculator and get the decimal version. But my two answers will be that x is equal to 1 plus the square root of 87, and then x is equal to 1 minus the square root of 87. Because remember, all of these answers or all of these questions will have two solutions, and this is how they're going to show up for this video. Okay, so like I said, it's a lot of steps. It takes a lot of space and room to do this, but they're not terrible steps. So let's look at the second equation, or the second example. The second example is x squared is equal to 10x minus 16. So once again, we want to get it in that form where the x's are on one side and then the thing without the x is on the other side. So in this case, what I'm going to do is subtract 10x from each side. When I subtract 10x, the 10x on the right side cancel out. And then we can't combine the x squared and the minus 10x because they're not like terms. One has an x squared and one just has an x. So we just kind of stick them together and say x squared minus 10x. And that's equal to negative 16. That 16 still has the negative on it. We didn't take that away. So now it's in the right form. Once it's in that right form with the x's on one side and the chunks without the x's on the other, we're going to use that completing the square formula, which is b over 2 squared, where b is the number with just one x. In this case, it's going to be negative 10. So we're going to say negative 10 over 2 squared. And when I plug that into a calculator, I should end up with 25. And kind of a trick here, because you're squaring them, all of your answers for these completing the square formulas will always be positive. Even if you put a negative in for b, it'll always be positive when you pull it out. And so every time we add something to each side, we will add it. We won't subtract it. Okay, so now we have this 25, and like last example, we're going to add it to both sides. So I'm going to have x squared minus 10x. I didn't change that, but I am going to say plus 25 right here equals negative 16 plus 25, because what I do to one side, what I add to one side, I have to add to the other side to keep the equality. And the reason why I add it is because now this side is considered a perfect square. Now in the last example, I showed you how to do the box method and that it'll work. It'll give you the same two factors. This is kind of the quick and dirty method. But because I know that it's supposed to be a perfect square, what I can do is I can take this middle number, this b number on this side, which is negative 10, and divide it by 2. When I divide it by 2, I get negative 5. That's what I put, excuse me, with my x's. So I know this side will factor out to x minus 5 times x minus 5. Now, once again, you could use the box method if you feel way more comfortable with that. Totally fine. But I'm telling you that because I know that it's a perfect square, all I have to do is divide that middle number by 2, and that tells me what my factors will be. And then on the right side, we have negative 16 plus 25, which gives me 9. All right, so now the next step is to combine the x minus 5s by saying x minus 5 squared is equal to 9. And then I like that that we have the squared and everything, but we want to get rid of the squared, so we're going to square root both sides. When I square root just the number side, I'm going to have to put the plus or minus on there like normal. The square root and the square cancel each other out on the left side, so I'm just left with x minus 5 on this left side. And then on the right side, we're left with plus minus the square root of 9. The good news is the square root of 9 can be simplified. That's 3. So I can write this as x minus 5 is equal to plus or minus 3. Then I can add 5 to each side to get the x by itself. The 5's cancel out over here. We're left with x is equal to 5 plus or minus 3, which can be written as, I'm going to scroll down a little bit, 5 plus 3 or 5 minus 3. And because those are both like terms, we can actually add them together. We don't leave them like that. 5 plus 3 is 8, and 5 minus 3 is 2, so 8 and 2 are my answers. So x could be 8, x could be 2, but those are both my answers. Okay, once again, lots of steps right here, but they're not crazy steps. Okay, the third example is actually already in a really good form where you have the x's on one side and the chunks without the x's on the other side. But this one, there's a slightly new rule or an extra rule that we need to take care of. So in the last two examples, excuse me, in the last two examples, we didn't have an a term where there was just an x squared. There was no number in front of the x squared. Because there was no number in front of the x squared, we got away with skipping a step. But when you have a number in front of the x squared, you have to do something before you can do the completing the square formula. And what you do is you have to factor that number out. Whatever the number in front of the x squared is, you factor it out of the left side of the equation. So what that means is I'm going to take the 8 and I'm going to put it outside of a set of parentheses, and then I'm going to divide each chunk on the left side by 8. So 8x squared divided by 8 would just give me x squared, and then 16x divided by 8 would give me a 2x, because 16 divided by 8 is 2. And I only do it to the left side of the equation. The right side of the equation can definitely stay 24, totally fine. Now that I have this here, what I'm going to do is that now I'm going to use the b over 2 squared formula, the completing the square formula, because this completing the square formula only works if your a term is 1. So now I can write it, my b term is 2, so I'm going to say 2 over 2x, which gives me 1, and I'm going to add 1 to each side. But this is kind of weird, so watch this. I'm going to put this 8 on the outside, because I didn't get rid of it, I just factored it out. So I have to keep it there. And then we have x squared plus 2x. And then we figured out our completing the square number is 1. So I'm going to say plus 1 right there. But then I'm going to say equals 24. Instead of adding 1 right here, I'm going to add 8 times 1. The reason why I have to add 8 times 1 is because if you look at it inside that, this 8 right here is going to multiply everything inside of this set of parentheses. And inside of that set of parentheses is the 1. So I'm not really just adding 1 to that side, I'm adding 1 times whatever's on the outside of the parentheses to it, which means that on the right side I also have to add my completing the square number times whatever's on the outside of the parentheses. Okay, so now that we have that, we know that the stuff inside the parentheses is a perfect square. We're going to use our quick and dirty version of factoring, taking that middle number right there, that 2x dividing by 2, so 2 divided by 2 gives me 1, which means that I know my factors will be x plus 1 and x plus 1. And then I can't forget about that 8. That 8 still stays there because I didn't get rid of it. I just factored it out. And then on the right side we have 24 plus 8 times 1. Well, 8 times 1 is just 8. So 24 plus 8 is 32. Okay, now the next step is to combine those x plus 1s. I can write it as 8 times x plus 1 squared equals 32. And then I want to get the x by itself. So normally we would square root at this point, but we have that 8 in front. Because we have the 8 in front, before I can square root, I'm going to divide each side by 8 to get rid of the 8. So the 8's cancel out over here on the left, and we're just left with x plus 1 squared is equal to 32 divided by 8, which is 4. Now I'm going to square root both sides because that's the next step. When I square root, I have to do the plus or minus. The square and the square root cancel each other out on the left side. I'm just left with x plus 1. And then we have plus or minus the square root of 4. Now the square root of 4 is 2. That will simplify to just be 2. Then to get x by itself, I would subtract 1 from each side. And the 1's cancel out over here. We're left with x is equal to negative 1 plus or minus 2, which can be written as negative 1 plus 2 or negative 1 minus 2. And negative 1 plus 2 is a 1. And negative 1 minus 2 is negative 3. So these are my two potential answers. Okay, one last example that will look really similar to that third example where we have to factor out a number first. And it's 9x squared minus 18x plus 8 is equal to 0. So first steps first, we still want to get it into that form where excuse me, where the x's are on one side and the chunks without the x's are on the other side. So I'm going to subtract the 8 from each side. The 8 cancels out over here. We're just left with 9x squared minus 18x, and then that's equal to negative 8. Now, because you have a number in front of that x squared, we're going to factor it out. So I'm going to write the 9 out here and then divide each chunk by 9. So 9x squared divided by 9 gives me just an x squared, and then a negative 18x divided by 9 gives me a negative 2x. And remember, you're only factoring the 9 or the number in front of the x squared from the left side of the equation. Now that the x squared's by itself, it doesn't have a number in front, we can use the completing the square formula, which is that b over 2 squared. And our b now is negative 2. So we have negative 2 over 2 squared, which gives me 1. All right, now that 1 I'm going to add to both sides, but remember it's kind of like a tricky add way. So we're going to add 1 to the left side. But because that 1 is in parentheses, that's being multiplied by 9 on the right side, I'm going to say negative 8 plus 9 times 1 instead of just 1. Then this chunk right here inside the parentheses is a perfect square. You could factor it, but we can also say, well, I'm going to take that middle number, which is negative 2, and divide it by 2. You always divide it by 2, which gives me a negative 1, which means that I'm going to have 9 times x minus 1 times x minus 1 equals negative 8 plus 9 would give me a 1. Then from there, we're going to get those x minus 1s together. So I have 9 times x minus 1 squared, because there's 2 of them, equal to 1. Before I can square root, I've got to divide each side by 9 to get just the squared part by itself. The 9s cancel each other out. I'm left with x minus 1 squared is equal to 1/9. Then I'm going to square root both sides. When I square root the number, it's plus or minus. The square and the square root cancel each other out on this side. I'm just left with x minus 1. Then on the right side, I have plus or minus the square root of 1/9. Now you can plug that into a calculator. It's going to give you 1/3. The reason why it gives you 1/3 is because when you square root a fraction, it's square rooting the top and square rooting the bottom. So the square root of 1 is 1, and the square root of 9 is 3, which makes it plus or minus 1/3. Okay, then the last step, if I want to get x by itself, I'm going to add 1 to each side. And the 1s cancel out over here. I'm left with x. And then on the right side, I would have 1 plus or minus 1/3, which is the same thing as saying 1 plus 1/3 or 1 minus 1/3. 1 plus 1/3 is 4/3, or like 1.33 repeating. And 1 minus 1/3 is 2/3 or 0.66 repeating. So both of those are my answers. And this is how we solve quadratics by completing the square.